Raise your hands if maths is your favorite subject. Impressive, Slapany. Sneezana, is it up or is it down? Toxayan, I'm surprised maths isn't your favorite subject. You scored better than all your classmates in your calculus exam last month. Bash and Dopey, I'm really not startled. You both failed your geometry classes. Snezana, is that what you're gonna do for the whole class today? Okay, so today we're gonna solve a very interesting, or should I say electrifying problem. This is a 5-pin socket. Imagine a world where humans derive their energy from electric current. So it's a hypothetical world because in real world, you'd get electrocuted. Now, I need a volunteer. Happiny, I'm choosing you. So Happiny is a resident of this hypothetical world. Let's call it electrodice. Happiny puts 2 of her fingers in the socket and derives the energy. How many total ways exist in which Happiny can derive the energy? Please note that each pin is different. Now this is a counting problem. There's a whole branch of mathematics, by the way, that deals with counting problems, and it's called combinatorics. So to solve this problem, we need to learn 2 things: the multiplication principle of counting and the formula for finding the number of combinations. The multiplication principle of counting says that if one thing can be done in X ways and another thing can be done in Y ways, the total number of ways in which both the things can be done simultaneously are X into Y. And by both the things, I mean that you have to do both the things. You can't do either one thing or the other. For instance, a pizza shop has 3 different types of pizza base and 5 different types of toppings. If a pizza can be made using only one kind of base and one kind of topping, the total number of ways you can make a pizza would be 3 into 5 equals 15. Because you have to choose a base which can be done in 3 ways, and you have to choose a topping which can be done in 5 ways, and you have to do both to make a pizza. So according to the multiplication principle, total ways would be 3 cross 5, 15. If you have n distinct things available, and you have to select any r out of those, the number of ways you can do that is NCR, which expands to n factorial divided by the product of r factorial and n minus r factorial, where n factorial is defined as a product of first n natural numbers. I think we have everything we need to solve the problem now. You see, the 5-pin plug consists of 5 distinct pins. Happiny has to insert 2 fingers to get the energy. Since each pin is different, we have to select any 2 pins in which Happiny would insert her fingers. How can we do that? Apply the combination formula. We have 5 pins available and we have to select any 2, hence 5C2, which equates to 10. Now Happiny has to insert 2 fingers, but which 2 fingers? We have 5 available fingers: thumb, index, middle, ring, and pinky. Again, 5C2. That is 10. So to get the energy, we have to perform both the tasks. We have to select the pins and the fingers. So we multiply 10 and 10 and we get 100. So Happiny happens to have 100 different ways to derive the energy. Can you guess the answer if all the holes were treated the same? I guess maths isn't boring after all. Did you have fun? Thanks for watching.